I calculate these without a calculator. So number 2, this one is 5 divided by 1. So how many times does 1 go into 5? 5 times. There's our answer. And then this one, 12 divided by 12. So it's this 12. And I'm dividing this by this 12. And how many times does 12 go into 12? Once.
I think you skipped one too. Oh, okay.
Which is kind of like number 4. Yeah, no, you're fine.
Well, my thing was just really...
So this one, we got 0 divided by 4. This one would be written as 0 divided by 4. So how many times does 4 go into 0? Well, 0 times. That's it. Now, as it turns out, 0 divided by anything is always going to be 0. So if that 4 were an 8, a negative number, a decimal, even another fraction, that answer would still be 0.
So basically 4 and 6 are the same.
So yeah, we'll keep this one up here so we can compare these two. And we're dividing 8. I'm sorry, we're dividing 0 by
So
8
now
by
we're
0.
seeing how many times 0 goes into each.
There you go.
Oh.
So if I use long division on this, and this is where this hopefully will help you understand why it is what it is. So again, the question for this is how many times does 0 go into 8? Now if I made the list like we did before, then I'd have a 0, a 0, a 0, a 0, lots of zeros. In fact, it just keeps going forever and ever and ever. So how many zeros are in an 8?
8.
Now technically we would say that there's an infinite number. But for the sake of us, we'll just say that it's undefined. Well, technically infinity is undefined, but whatever. You guys didn't want to know any of that garbage, did you? But 0 goes into any number an infinite number of times because, well, you can put a 0 into any number 100 times, but then you could put it into it another million. And once you get to a really big number, then it just keeps getting bigger and bigger and bigger, and so it's undefined. Yeah, and that's kind of the way we look at it, is we would say it's either 8 or 0, depending on how we're thinking about it, right? Now 6, though, is very similar to 5. In fact, it is just like 5, except for we got a different number. So this one would be 0 divided by, I'm sorry, I did that backwards. 4 divided by 0, that's better. And how many zeros go into 4? Once again, that would be undefined. Now the zeros first. So this one ends up being,
7.
I got 0 divided by 7. And how many times does 7 go into 0? 0. Now again, if I made the list, right, I'd have a 7, 14, 21. Technically, we could say that the value 0 is missing from that. Because 7 times 0 is 0. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21, and so forth. So we can show that 7 times the 0 would give us this 0. All right, so number 8. This one we got 56 divided by 7. So I've got a 56 divided by 7. Well, 7 doesn't go into 5. 5 is too small. So I'm going to treat this as 56. So 7 goes into 56. Let's see. 7, 14, 21, 28, 35, 42, 49, 56. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 times. Now to really finish this off, I would take the 8 times the 7, which is 56, and subtract it to see if I have anything remaining on that. But for this one, I have 0 remaining. So the final answer is just 8. Yeah, so let's set that one up right now. So I got 210, and we're dividing this by 3. So once again, 3 does not go into 2, but it will go into 21. I think we did that one already. 3, 6, 9, 12, 8, 15, 18, 21. So that's 7. So 7 times 3 is 21. So I'm going to subtract that out. And then I got a 0. I'll drop that 0. And yeah, 3 doesn't go into 0 any times. So that's a 0 there. And yeah, my final answer is that 70.
Oh, 7.
So here's the nice thing is if we're, remember the 0 thing with the multiplication, there's kind of a rule for dividing with zeros as well. So I got 800 divided by 10. As it turns out, I can cancel out zeros this way. Now we got to be careful on this though, all right? Because it's only true for division like this. And the zeros have to be on the far right for both numbers. So that means that if there was a 5 right here, I couldn't do that. Okay? But for us, in this case, there is no 5 there. So we're in good shape. See, what this does is it just makes this problem a little bit, I would say, simpler. Because I got 80 divided by 1. So let's look at the long division on that. 80 divided by 1. Right? So 1 goes into 8 times. 8 times 1 is 8, so I subtract that out. I get 0, drop this 0. 1 goes into 0 times. So the answer is just 80. And we may have remembered that anything divided by, we haven't really said it in this class, but anything divided by 1 is itself.
Kind of like times tables.
Kind of like times tables, yeah. Anything times by 1 is itself. Anything divided by 1 is also itself. So on this one, let's say maybe that there was some kind of number where we got this 2 zeros here at the bottom. Then there would be some kind of remainder. But for us there wasn't, so we don't have to worry about it. But that's something we need to keep track of if there is, which we'll see on this next problem here. So when asked for the quotient, it wants how many times, essentially, that 7 goes into 5,574. How many times does it do that? But then if we have a remainder, then we would state what the remainder is, like this. Okay. So let's look at this using long division. So I've got my 5,574 divided by 7. And again, it may be helpful to see multiples of 7. So 7, 14, 21, 28, 35, 42. So I'm just adding 7 to each of these as I go down. 49, 56. And let's see if we need any more than that, okay? So 7 won't go into 5, but it will go into 55. We can see there 7 times. It doesn't quite make it to that 56. So 7 times 7 is the 49. Again, I'm just using the chart. And now I subtract. So for this 5 minus 9, I'm going to have to borrow from this 5 and make that a 15. Minus 9 is 6. 4 minus 4 is 0. That's good. Well, 7 doesn't go into 6. That's good. That means we did that right. And then I got to bring this 7 down. See, now I'm looking at 67, which means that 56 isn't big enough. So I got to add another 7 to get 63. Well, 7 goes into 67 9 times then. And 9 times 7, as we can see in the chart there, is 63, which I will subtract out of the 67, and that's 4. But then I need to drop this 4 as well. And I can see that 7 will go into this 44 6 times right there. So that would be 6 right there. Very good. And then I subtract this, and I've got 2 remainder. So I got 796 times. Guess how many times this will go into the 5,574 with a remainder of 2. Now, if we had done this on a problem regularly, we could just write it like this. 796 R2, the R for the remainder. So here we go on this one. So I got 9,024 divided by the 9. And again, it may be helpful to see this with the multiples of 9, right? So we got 9, 18, 27, 36, 45, 54, 63, 72, 81. All right, so 9 goes into 9 once. So 1 times 9 is 9. Subtract. That's a 0. So I'm going to carry down this 0. 9 goes into these zeros 0 times, so I got to carry out this 2. 9 still doesn't go into 2. So I've got to carry down a 4 and make this 24. 9 goes into that 24. Looks like it will go into it twice. 2 times 9 is 18. And subtracting this, I got to borrow 1 from the 2. And that looks like it's 6. So the quotient would be 1,002 with a remainder of 6. Of course, we could write it like this as well. Alright, calculated these without a calculator. Show all steps. Alright, so 16, once again, I like to see a list of multiples of 23. So I'd get 23, 46, 69, 2, 1, 3, 92, 5, 11, 5, 8, 138, 161, and let's see if we can get away with the next one. So 4, 184. Let's see if this will do it. And so far we got 23, which will not go into 8, but it looks like it will go into 83. That's 3 times. So 3 times the 23 was 69. So 3 minus 9, I got to borrow 1 from the 8. 13 minus 9 is 4. 7 minus 6 is 1. So I got 14 there. I'll need to drop the 0 because 23 does not go into 14. And I got this one right here that we can use. 1, 2, 3, 4, 5, 6. 6 times 23, we can see there's 138. So we'll subtract that out. And we'll make that a 10. 10 minus 8 is 2. And then 3 minus 3 is 0. 1 minus 1 is 0. And bring the 3 down. And then 23 goes into 23 exactly 1 time. So that would give us 23 minus 23 here. And we got 0 remaining. So the final answer there is 361. Let's look at this translate and simplify stuff. So translate and simplify, when we look at division, there are some words we need, and one of them is quotient right there. Quotient means division. Let's put that on here, quotient. And then, of course, divide works because it is division. Sometimes you'll see into, you'll see a ratio, per something means division. Shared equally, divided by, I don't know. These are kind of the main ones. But we just may see some of this other wording as we go as well. Hopefully we'll see quotient more often than not. But when on 17 it says the quotient of 14 and 2, it means we're going to take 14, and since its quotient is division, we're going to take 14 and divide it by 2. So up here we can do the work. 14 divided by 2. 2 doesn't go into 1, but it will go into 14 7 times. So minus the 14, 0 remaining, and the answer is 7. So this one is worded differently enough where we need to take that into account. 4 divided into 24 is really saying how many times does 4 go into 24. So I mean, if we wrote it out, it would be 24 divided by 4 like this. But since we are using long division, it's how many times does 4 go into 24 like this. 4 doesn't go into 2, but it will go into 24 6 times. Exactly. So 0 remaining on that one. For each problem, decide if you should add, subtract, multiply, or divide, then calculate the result. Since this is the division portion, we should be looking to divide for the most part, okay? So 4 roommates agree to split the $1,500 rent equally. How much will each pay? This one is going to be division because we're dividing $1,500 rent amongst the 4 people. So we'll calculate this one. So 4 doesn't go into 1, but it will go into 15 3 times. 3 times 4 is 12. So I got a 3 there. I'll drop this 0 down here. 4 goes into 30 7 times. 7 times 4 is 28. Which leaves me with 2. I'll drop the 0 there again. 4 goes into 25 times. Which leaves us with 0 remaining. That's good. So the answer to this one would be $375 for each roommate. So the team for the Alzheimer's Walk has raised $375. How much more do they need to raise to reach their goal of $1,000? So this one tells us how much they have raised and how much they need. So this one I would say we're going to use subtraction. Right? Their goal is $1,000. And to figure out how much they need to raise, we're going to subtract what they have already raised, $375, like this. All right, so we need to borrow on these, right? So I got to make that a 10. That'll be a 9 and a 9. So we'll borrow that 1. So 10 minus 5 is 5. 9 minus 7 is 2. 9 minus 3 is 6. So they still need to raise $625. Yeah, so let's show these, but since we're kind of short on time, we'll not solve them, okay? So let's just set them up. So 21, a car insurance quote is $744 for 6 months. How much is that every 1 month? So in this case, we would use division. 744 divided by the 6. 22, your friend with a flock of chickens wants to give you 65 eggs. How many egg cartons with a dozen should you take with you to carry the eggs?
So would it be 65 divided by 12?
That's correct. Very good. Because you got the 65 eggs divided into 12 egg cartons. Now, if you make $2,240 a month, how much do you make each year? This one actually is multiplication, because this is how much you make a month, and you're going to do this for 12 months. So you have 12 groups of that. So this one's multiplication. If you make $2,240 a month, how much do you make a week? Assuming there are 4 weeks in a month. Now it is division, because we're going to take the monthly value and divide it into the 4 weeks. All right, Maria is planting a row of flowers in a bed, 35 feet long. The instructions say to space the plants 1 foot apart. The flowers came in flats containing 6 plants per flat. How many flats will she need? How many plants will she have left over? Yeah. So let's look at this. So we got 35 feet. Let's say that this is 35 feet here. And if I have a plant right here, then I've got to have a 1 foot space right here, right? Now if I got 6 plants per flat, all right, I overcomplicated that. I apologize. So if I have a plant here on the end, then I've got another foot for the next plant, another foot for the next plant. So in other words, I could put 35 plants in this, which means I'm just going to simply divide this. 35 divided by 6. And that would tell us how many flats she needs. It looks like she's going to need 6 flats. And then she would have one plant left over. right, so let's look at this, how this works, because that may be a little confusing. So 6 goes into 35 5 times. That gives us 30. Now this has a remainder of 5, but I can put those 5 plants into the garden because I got 35 feet. So that just tells me that's why I need the 6 flats, because I need enough plants to put into the garden. Now the 6 flats would give me 36 plants, and if I plant 35 of them, then I would have 1 left over.